Another common method of burning coal on smaller boilers is by use of a traveling grate. In this arrangement, coal is fed from the chute onto a grate, which then carries the coal bed into the furnace. The grate is really a continuous conveyor made of very rugged material to resist heat, erosion, and corrosion. Initially, the bed of coal does not ignite as its temperature is too low for ignition. However, after a few seconds, as the bed continuously moves forward, its temperature rises due to radiant heat transfer from the existing flame and refractory arch, and ignition takes place. Forced air for combustion is fed up through the grate. The wind box beneath the grate is compartmentalized with individual damper controls, so that the distribution of air may be biased towards the front or back end as required. Generally, secondary air or over-fire air is admitted into the furnace at a higher level to complete combustion. As the grate continuously moves forward, the coal on the bed burns, leaving ash to be discharged into the ash pit, as the grate follows its continuous path and returns again to the coal feed. Control over the heat input to the boiler and consequent steam output is affected by adjusting the thickness of the coal bed on the grate, the speed of travel of the grate. The correct distribution of air is vital if complete combustion is to be obtained. Several inherent problems exist with this type of burning equipment. One is the potential for combustion to be incomplete and consequent discharge of combustible material into the ash pit and then to waste. Another potential problem is the failure of the coal bed to ignite, so that the whole bed of green coal may be discharged into the ash pit, while the boiler rapidly loses pressure. Another serious problem is caused by slag forming on the grate. This is due to metallic elements in the ash becoming molten and sealing the grate so that combustion air cannot pass through. This means that the coal cannot receive air for combustion. More serious yet is the fact that the grate overheats and may well distort and become physically damaged. Like all boilers, the traveling grate requires careful control of operation. Another type of traveling grate, known as the spreader stoker, employs a grate which is traveling in the reverse direction, that is, towards the front of the boiler. In this arrangement, the coal is thrown into the furnace at a higher level, like this. This means that a certain amount of combustion takes place in suspension, similar to a pulverized coal furnace. The remaining coal eventually falls to the grate, where it continues to burn in the conventional traveling grate manner. Ash is finally dumped into the ash pit as the traveling belt turns. This type of spreader stoker arrangement is sometimes used for burning waste material. Now at this point, we'll take a break and then come back and look at combustion equipment for burning low-grade fuels, such as municipal waste. Please switch off the video and review this material in your workbook. In this segment, we'll take a look at combustion equipment used to burn low-grade fuels. A low-grade fuel usually contains one or more of the following undesirable characteristics. Highly variable content, municipal waste, for example. Low heat content, high ash content, low ash fusion temperature. The effect of low ash fusion temperature is particularly onerous. It results in heavy slag formation on boiler tubes, superheaters, and other areas. This often leads to blockage of gas flow through certain sections of the boiler, as well as loss of heat transfer and consequent reduction in boiler output. The term low-grade fuel is used to describe such items as municipal and industrial waste, agricultural waste known as biomass, coal with low ash fusion temperature, petroleum coke, wood waste, waste from coal treatment facilities, peat. Ideally, waste or refuse should be sorted before it is fed into the boiler for combustion. That is, the non-combustible materials, such as glass and metals, should be removed so that combustible material only, such as paper, wood, cloth, etc., is supplied to the boiler. Generally, waste material and wood are burned on a fixed grate, usually sloping like this. Combustion air is fed up through the grate and needs to be carefully controlled so as to complete combustion and not blow the material off the grate. The ash eventually falls to the bottom of the slope and enters the ash pit. In another common arrangement for burning refuse, the material is burned on a dump grate, which intermittently opens like this to dump ash. Spreader stokers, as shown in the last segment, are also employed to burn waste material. There are, of course, many variations of these schemes for burning solid waste. Indeed, this task appears to be as much an art as a science. Successful operation of these boilers depends very much upon the experience of the plant operators.